Everybody understands everything. Wow. Great. So let's look at something new today. So I had explained this problem yesterday to you. From 11 spell again. Problem 6.3. An aqueous reactant stream with concentration 4 moles of A per liter passes through a mixed flow reactor followed by a plug flow reactor. Find the concentration at the exit of the plug flow reactor if in the mixed flow reactor Ca is equal to 1 mole per liter. The reaction is second order with respect to A. The volume of plug flow reactor is 3 times that of mixed flow reactor. So we are going to do this problem. A mixed flow reactor. And we have feed coming in. Concentration is given as 4 moles per liter. And in the Ca is given as 1 mole per liter. So what we get out of this is a stream with Ca equal to 1 mole per liter. And that is going to a plug flow reactor. And what we need to find is concentration at the exit of the plug flow reactor. So we need to find, I call this as Ca1. So we need to find what is Ca2. Is the problem definition clear to all? Plug flow reactor is always horizontal. Mixed flow reactor is normally represented vertically. And what is given is n is equal to 2. And what is also given is, suppose this is V1 and this is V2. V2 by V1 is equal to 3. You should be always able to translate the problem statement into a kind of block diagram as we used to do in PC. You should understand what is coming in, what is going out, what is given, what is not given. Is it clear to all?
Yes, sir.
Okay, so what we need to do is, how will you find out? You need to find out the CO2. How to find out CO2? Any idea? We done a similar problem. Only thing is, it was 2 mixed flow reactors, which we did yesterday, 6.1. Now instead of 2 mixed flow reactors, it is 1 plug mixed flow reactor followed by a plug flow reactor. That's the only difference.
So first of all, we need to find the value of K in terms of V0 and V of MFR.
Right.
Then put it into the performance equation of PFR, and after solving, we will get the Ca2 constant.
Excellent. So this volumetric flow rate is going to be the same. It's not going to change. So what we can do is we can find out what is the value of K from MFR and then use it in the PFR and find out what is the value of Ca2. Because n is given, k is not given, so we use always one set of data. पहले भी explain किया मैंने आपको. Use one set of data which is given to find out what is the unknown in terms of rate equation. In this case, rate constant is not given, so you have to find rate constant. Then you can use it in the PFR and find out what is the concentration at the end of PFR. Okay, so let's start. Let's see who can find out k value. It will be in terms of V1 and V0. It will not be absolute value, it will be in terms of V1 and V0, because we know what is V1, we don't know what is V1, and we don't know what is V0. But it doesn't really matter because we can substitute in PFR and cancel out. Okay, so let's find what is the value of K from mixed flow reactor data. Okay, this should be easy. Mixed flow reactor equation is very simple, which you already used yesterday. कर सकते हैं कि नहीं?
Yes, sir.
Or once you finish calculation, raise a hand and let me know what is the value of K. What is the value of K, Dikshita?
3 V naught by V1.
Excellent. Where was same thing you're getting?
Yes, sir.
Good. Excellent. It's very straightforward. Mixed flow reactor is very simple always.
Sir, Ca2 I am getting is 0.10811.
0.1 आएगा exactly.
Yes, sir. 0.10.
Exactly 0.1 आएगा. इसका हो गया. Can proceed to plug flow reactor and find what is the value of Ca2. और किसका हो गया K value? Raise your hand. रितेश नहीं हुआ क्या अभी तक?
हो गया आगे का कर रहा हूँ.
PFR कर रहे हो, ठीक है. देवेंद्र
हाँ.
हो गया K value?
हाँ सर कर दो.
अरे कर रहा है, कितना टाइम लगता रे? सिद्धि, ये क्या सिद्धि? नुपुर,
Yes, sir. I'm actually solving. I'm a little confused because I was not there last week.
yesterday you were not there.
No, sir.
No?
Sir, I was actually traveling, so I was in the car.
Your wish. And what about ठीक है, बाकी लोग कर रहे हैं कि नहीं कर रहे? ऋतुजा,
कर रही हूँ सर।
जितना करोगे प्रॉब्लम्स उतना आपको समझ में आएगा। नोट्स से कुछ समझ में नहीं आने वाला है ज़्यादा, बस एक्चुअली डूइंग इट हेल्प्स यू अंडरस्टैंड। That is why we solve so many problems in CRE1 and CET and all, and PC. Observation does not help. सिद्धि, हो गया क्या?
नहीं सर। सर वो रेंज का इशू था थोड़ा,
अच्छा,
आवाज नहीं आ रही थी।
अभी आ रहा है आवाज?
हाँ सर।
ओके, के वैल्यू हो गया कि नहीं हुआ?
हाँ हो गया सर।
ओके, ठीक है। सो नेक्स्ट गो टू PFR and do the PFR calculation. वैसे ये किया क्या कुछ?
सर कर रहा हूँ।
के वैल्यू आ गया? मुर्तजा कुछ कर रहा है कि नहीं कर रहा है, कि बैठा है सिर्फ टाइम पास कर रहा है? मुर्तजा, सोते रहते लोग। अच्छा, while you are doing the problem, I have a announcement. Your test for Unit 3 will be next week on Thursday. Now I have a question. Do you want numericals or you want MCQs? देवेंद्र, Dikshita, can you hear me?
Yes, sir.
You want MCQs or you want numericals?
Both are fine.
Both are fine, नहीं डिप्लोमेटिक आंसर नहीं देने का। I would prefer numericals because that really tests your what you learnt. MCQ तो easily हो जाता है।
Numerical sir.
Give a numerical. I'll give an assignment today from where you'll get exam questions. Maybe not class problems, but something from the assignments. So if we work on the assignments, complete the assignments, all questions, although you have to submit only one question, it is better to work on all the problems so that you get a practice. You can practice for problem solving. और किसका हो गया CA2? Raise your hand. नहीं हुआ किसी का? CA2 only one person has done, is it? रुको उधर जादव, कुछ कर रहा है कि नहीं?
हाँ सर कर रहा हूँ।
ये हो गया क्या? अरे कितना टाइम लगता है रे ये फर का करने के लिए? सो सिंपल। ठीक है, ये परफॉर्मेंस इक्वेशन फॉर पर सी ए नॉट माइनस सी अपॉन माइनस आर ए और सी ए नॉट एक्स ए अपॉन माइनस आर ए होता है, बट वी आर गोइंग टू यूज दिस फॉर्म बिकॉज यू नो द concentrations. You know C A naught, you know C A. So you can write tau 1 and this is 1 C A 1. So it is V1 upon V naught is equal to 4 minus 1 upon K into C A 1 square. Right? But minus R is nothing but and concentration is C A 1 in FR. So it is K into C A 1 square is 3 upon K because C A 1 is 1. You can write K as 3 V naught upon V1. It's very straightforward. You don't need to be in the class. अगर आपको यूनिट 1 भी समझाए तो कर सकते हो यूनिट 2. So next we'll go to PFR. What is the performance equation of PFR? What equation will we use? Who can tell me equation to be used for PFR? Can you hear me?
सर इंटिग्रेशन ऑफ C1 to C2. Okay.
Yeah, integration CA1 CA naught to CA जनरल इक्वेशन लिख रहे हैं हम. तो ये हो जाएगा CA naught to CA. क्या हो जाएगा इंटीग्रल में? क्या आएगा?
C0 minus CA upon K into CA.
नहीं, DCA. Integral is always DCA and minus. इक्वेशन आपको याद रहना चाहिए. So in this case tau 2 is equal to minus CA1 to CA2 dCA by K. क्या हो जाएगा? CA होगा CA2 CA होगा CA स्क्वायर रहेगा. राइट? ठीक है. तो दैट इज द राइट इक्वेशन. तो इंटीग्रल क्या हो जाएगा इसका? What is the integral of dCA by CA square?
minus 1 upon
minus
C.
1.
Minus 1 upon CA. Then in limits are CA1 to CA2. Right? So it is minus minus plus हो जाएगा. Nothing but V2 upon V0. Right? And K we know is 3 times V0 upon 3 times V0 upon V1. बराबर. K की वैल्यू डाला हमने. वन अपॉन CA2 पता नहीं है हमारे को. minus 1 upon CA1. CA1 is what? 1. Right? So 1 upon CA2 minus 1 equal to इधर लेके आ गए तो 3 times V0 upon V1 into V2 upon V0. So V0 cancels out, and what you get is V2 upon V1. And what is V2 1 given as? 3. So what you'll get is 3 into 3. So what you get 1 upon CA2 is equal to 10 हो जाएगा. बराबर. तो 1 इधर लेके आया, 9 plus 1 10 हो जाएगा. So CA2 is nothing but 1 upon 10, which is 0.1 moles per liter. ठीक है. Any doubts, questions? कितने लोग का on their own calculation हुआ था before I solved it? Raise your hand. Nobody. क्यों इतना डिफिकल्ट है क्या? रितेश.
नहीं सर, वो परफॉर्मेंस इक्वेशन गलत लिखा है, इसलिए आगे का इंटीग्रेशन गलत हो गया.
I already told you, if you know
हाँ.
MFR performance equation, you can write PFR performance. इसमें क्या फर्क है? Tell me.
हाँ सर, वो जल्दबाजी में गलत लिखा है.
जल्दबाजी क्या होती है? This is minus DCA. Well, see, DCA is always CA2 minus CA1 or CA1 minus CA0. Right? Minus DCA आएगा, upon minus RA. There's no difference between PFR and MFR equations. There's only an integral there, that's all. Because PFR, the concentration is continuously changing, whereas in MFR it is constant concentration. अगर फंडा समझ में आया तो you can write this equation anytime. देवेंद्र, क्या हो गया? नहीं है क्या देवेंद्र? गायब है. ओके, दीक्षिता.
Yes, sir.
क्या डिफिकल्टी आ रही है?
कैलकुलेशन गलत हो गया था.
कैलकुलेशन है तो नॉट कॉम्प्लेक्स कैलकुलेशंस. शिवानी नहीं. सिद्धि.
Sir, performance equation.
परफॉर्मेंस इक्वेशन में क्या डिफिकल्टी आ रहा है आप लोगों को? मैं एक्सप्लेन किया, आपको समझ में नहीं आया क्या? How to remember that?
हाँ सर, पर थोड़ा कंफ्यूजन हो गया था इसलिए।
ठीक है, नुपुर समझ में आया क्या आपको?
Yes, sir, I followed.
It has nothing to do with यूनिट 3, पूरा यूनिट 2 का ही है पूरा। यूनिट 3 में ठीक है, पीएफआर का इक्वेशन डिराइव किया था परफॉर्मेंस इक्वेशन यू कैन सॉल्व एनी प्रॉब्लम, उसमें ज़्यादा कुछ है ही नहीं, देयर इज हार्डली एनीथिंग। ऐसा लगता है कॉम्प्लेक्स है बट इट इज़ नॉट कॉम्प्लेक्स एट ऑल, सो यू हैव टू थिंक इट इज ईजी, देन ओनली यू विल डू इट। अगर आप सोचो कॉम्प्लेक्स है तो कॉम्प्लेक्स ही लगेगा। Anybody has any questions before we proceed to the next problem? ठीक है, अगर नहीं है क्वेश्चन तो लेट अस सॉल्व अनदर प्रॉब्लम, सिमिलर प्रॉब्लम है ये भी। अगेन 11th स्पेल का अनसॉल्व प्रॉब्लम है 6.17। द एलिमेंट्री इरिवर्सिबल aqueous phase reaction A plus B goes to R plus S is carried out isothermally as follows. Equal volumetric flow rates of two liquid streams are introduced into a 4-liter mixing tank. One stream contains 0.02 moles A per liter, the other 1.4 moles B per liter. The mixed stream is then passed through a 16-liter plug flow reactor. We find that some R is formed in the mixing tank, its concentration being 0.002 moles per liter. Assuming that the mixing tank acts as a mixed flow reactor, the important thing यही है, mixing tank acts as a mixed flow reactor, ये याद रखना चाहिए आपने। Find the concentration of R at the exit of plug flow reactor as well as the fraction of initial A that has been converted. That means we need to find out XA2 and CA2. ठीक है, प्रॉब्लम समझ में आ रहा है? Are you able to understand the problem statement? Does anybody have question on problem statement? नहीं है तो ठीक है, let's see. Now if you want to draw this, depict it. So we'll have a mixing tank which acts like a mixed flow reactor, बोला है उसने. And in this what we are doing is we are adding two streams, right? We have a stream equal volumetric flow rates, remember this also, equal volumetric flow rates of two liquid streams, right? So one stream contains, so if I take A, let me say इसमें है C A naught is equal to 0.02 moles per liter, and the other one is containing B, that is C B naught is equal to 1.40 moles per liter. And volumetric flow rate is suppose V naught here, and here also it is V naught. So many liters per, you can take anything, per minute, liters per minute. Equal volumetric flow rates of A and B liquid streams. One is 0.02 moles of A per liter, and Cb naught is 1.4 moles per liter. So I'll call this as C naught, Ca naught prime, and this also I'll call it Cb naught prime. Okay, so there's another stream which is B. ठीक है, इतना समझ में आया लोगों को? So we have two streams. Ca naught prime is 0.02 moles per liter and Cb naught prime is 1.4 moles per liter. They are mixed in this mixing tank. So there is a stirrer here somewhere. It is used for mixing these two liquid streams. And then what we get out of here is one stream which will have some Ca1 and Cb1. Okay. We find that some R is formed in the mixing tank, so some reaction takes place in this reactor or mixing tank, and what we have is CR1 is equal to 0.002 moles per liter. Right? And this volume V1 is equal to 4 liters. Okay. Then this thing is going to a plug flow reactor. Whose volume is 16 liters. So what we need to find is what is the concentration here. So we need to find out Ca2 and XA2. Okay. Any questions on this problem statement or understanding of the problem? How many people have not understood this problem statement?
सर यहाँ पे CS1 नहीं लेना है, रिएक्शन में S भी है ना, प्रोडक्ट
क्या बोल रहे हैं?
प्रोडक्ट में सर S भी है ना, R+S.
Doesn't matter, उसने CR1 दिया है.
ठीक है सर.
He's not talking about CS1. Doesn't matter. जितना CR रहेगा उतना CS रहेगा. Reaction says that, right? जितना R form होगा उतना S form होगा. So you know what is how much is S formed, but it is not important. ठीक है, समझाएगा प्रॉब्लम स्टेटमेंट लोगों को? How many people have not understood this problem? The understanding of the problem is half the solution. If you don't understand the problem, you can never solve the problem. वैभव समझा क्या? नहीं क्या वैभव? गायब हो गया होगी. ओके, हाँ राइट. दीक्षिता समझा क्या?
Yes, sir.
नुपुर
Yes, sir.
जी?
Yes, sir.
Okay, so how will we solve this? How to solve this? Because it's exactly similar to the previous problem. Mixed flow reactor followed by plug flow reactor.
P1 equal to N2V2 करके CA0 and B0 CB0.
Exactly, good. तो ये मेन पॉइंट यही है कि यहाँ पर प्रॉब्लम CA0 ने दिया है हमारे को, इनिशियल कॉन्सेंट्रेशन दिया which is before mixing. तो when they mix together, यहाँ पर जो मिक्सिंग हो रहा है तो CA0 और CA0 और CB0 निकालना पड़ेगा. we need to find out CA naught and CB naught at time t equal to 0. So first thing is find CA naught and CB naught after the two streams are mixed, but before the reaction occurs. That is at time equal to 0. Assuming that it is instantaneously mixed, so what is the concentration of CA and CB at time t equal to 0? Can you find out? पहले एक्सप्लेन किया है मैंने प्रैक्टिकल टाइम पर. Exactly similar procedure है, there's no difference. But you tell me what is the value of CA naught and CB naught. इसीलिए मैंने CA naught prime डाला है और CB naught prime डाला. That is before mixing, the concentration is different. After mixing, but before the reaction starts, the concentration is different.
CA naught is 0.01 moles per liter.
CB naught
0.7.
that. और किसका हो गया? Raise your hand. बाकी लोग क्या सो रहे हैं क्या? Nupur, have you understood how to calculate CA naught and CB naught?
Sir, I'm following, but I'm still calculating.
ठीक है. How are you calculating?
Trying to make sense of what's there on the screen.
Makes sense. You are missing so many lectures, so it is very difficult to make sense in.
Yes, so actually, I had an exam, so I kind of had to.
Yeah. Okay, so that means out of 40 students, only 2 students have understood. 38 students are sleeping and they don't care. Okay, doesn't matter. I can't help it here. So essentially what is happening is we have a mixing tank. In which you have 2 streams coming in. One is having CA naught prime equal to 0.02 moles per liter. Another is CB naught prime is equal to 1.4. 1. And the volumetric flow rate is V naught liters per minute for both. So suppose V naught is equal to 10. Liters per minute. Then I can use N1 V1 equal to N2 V2. This is nothing but material balance equation. So if I do it for A, initial concentration is 0.02. Volumetric flow rate is 10. Suppose. Final concentration I don't know. Volume V2 कितना होगा? Nupur? If I mix 10 liters of A and 10 liters of B, what will be total volume?
Why so, sir?
20 liters हो जाएगा ना? If I'm mixing V naught volume of liters or minute of A and V naught liters of B, total volume will be I just put some numbers instead of V naught. Calculate what is N2, which is nothing but 0.02 upon 2, which is 0.01 moles per liter, which is now Ca naught after mixing of the two streams. समझा क्या नुपुर? No response. ठीक है.
Yes, sir.
Similarly, I can do it for B. And I have 1.4 into V naught is equal to N2, I don't know, into 2 times V naught. Volume is doubling. So V naught cancels out, doesn't matter what the volume is, flow it is. And I'll get N2 equal to 1.4 upon 2, which is 0.7 moles per liter. Okay, so this is nothing but Cb naught after mixing. Any questions so far? Okay, so now you know Ca naught, you know Cb naught, and reaction जो दिया है, order क्या दिया हमारे को reaction का? कुछ दिया क्या reaction का order? Rate equation का? Is the order of reaction given?
No, sir.
It's not given.
सर एलिमेंट्री दिया है सेकंड
Exact.
ऑर्डर.
Excellent. So elementary reversible reaction दिया है, that means it is second order reaction. ये basic है, unit 1 है कि पता है, I think unit 1 ही है, right? So although they are not explicitly stated what is the order of reaction, it is implied that the order of reaction is 2. Right? So what is given is n is equal to 2. तो rate equation क्या हो जाएगा? K into
CA into CB.
EA into CB. Okay. Now if I look at CB naught and CA naught, can I conclude something? CB naught और CA naught वैल्यू लेके कुछ कंक्लूजन निकाल सकते क्या हम?
CB naught is greater than CA naught.
CB naught is much greater, not just greater, much
Pseudo
greater
first
than
order.
CA naught. 0.7 moles per liter, and this is 0.01 moles per liter. ये कितना भी रिएक्ट हो जाए, ये रिएक्ट इसमें कॉन्सेंट्रेशन ज़्यादा फर्क नहीं पड़ने वाला है. जरा भी रिएक्ट होगा तो 0.01 मोल्स पर लीटर रिएक्ट हो जाएगा, 0 हो जाएगा तो 0.69 हो जाएगा. Hardly any difference. So you can take CB is almost equal to constant, right? And then you can combine B with K, and what you'll get is what is this Question called reaction called.
Sir,
Yeah.
सर रिलेशन निकाल के नहीं पुट कर सकते
कौन सा रिलेशन निकालना है?
सर वो CB नॉट कितने टाइम CA नॉट का है
अरे है ना, यहाँ पर दिख ही रहा है। सी ये 0.01 मोल्स है, ये 0.7 मोल्स है। ये पूरा भी रिएक्ट हो गया तो कितना रिएक्ट होगा? 0.01 रिएक्ट होगा। मैक्सिमम ए कैन रिएक्ट इज 0.01, तो बाकी CB और CB कितना बचेगा एंड ऑफ रिएक्शन में?
सर CN तो 0
69।
6 नहीं है
क्या मतलब, क्या व्हाट इज डिफरेंस बिटवीन 0.7 एंड 0.69? कितना परसेंटेज एरर होगा?
बहुत कम सर
That's what exactly I have told you. It's almost constant. CB is almost constant. It's not going to matter. ये पहले समझाया था मैंने. And what is this called? Rate equation called
pseudo first order
pseudo first order. Because although it is second order, it behaves like a first order reaction. Because the concentration of one component is so high, it doesn't really matter कितना reaction हुआ. ठीक है, is that understood now?
yes sir
Right. So we have this thing now. So we know the rate of reaction. Now we need to find the value of K. बराबर. Ultimately हमारे को order मिल गया, but K नहीं पता हमारे को. We don't know K. How to find K? Is there anything given which can help us find the value of K rate constant?
from MFR MFR यूज
या
कर
क्या दिया है MFR के लिए जो हमको हेल्प करेगा फाइंड करने में K?
सर परफॉर्मेंस इक्वेशंस
परफॉर्मेंस इक्वेशन तो सबको पता है क्या है, बट व्हाट डेटा इज गिवन? डेटा कौन सा है हमारे पास?
सर CA नॉट है CB नॉट है
और क्या दिया है?
सर V1 है
हाँ, और थिंक अब आपकी आंखों के सामने ही है.
CR भी है।
CR वैल्यू दिया हुआ है. एक्सेलेंट. कौन बोला?
ऋतुजा।
Right. So this value we can use to find out what is the reaction, how much is reacting in the mixer or mixing tank or mixed flow reactor, right? And we know 1 mole of A gives 1 mole of R. So 1 mole of A reacts to give 1 mole of R, whatever. So if you know how much R is formed, we can find out how much A has reacted. बराबर है? Is that clear? PC.
Yes.
कभी नहीं भूलने का. Never forget PC. Equivalent statement will say 1 mole of A reacts with 1 mole of B to give 1 mole of R plus 1 mole of S. So if I know that 0.002 moles per liter of R are formed, how many moles of A have reacted? ये कितना रिएक्ट करेगा?
सर उतना ही
0.00.
नहीं, exactly. I write equivalent statement. So 1 mole of A ठीक है. So R formed is 0.002 moles per liter. So A reacted कितना हो जाएगा? Same 0.002 moles per liter. Okay. So if I know A reacted and I know Ca naught is equal to 0.01 moles per liter, can I find out Ca1?
Yes, sir.
What is Ca1 then? Sorry. What is Ca1? Ca1 is nothing but Ca naught minus Ca or A reacted.
Zero point 008.
So you should be able to work with the data and find out what is given and what is not given, but there's a way to find it out. So now we know Ca naught, we know Ca1. So can you find out the value of K? मिक्स्ड फ्लो रिएक्टर का परफॉर्मेंस इक्वेशन लेके कर सकते हैं, बराबर? ठीक है, तो करो. Let's see who can do it. Find the value of K.
So K is 0.0625 into
What is the value of K?
0.0625 V naught.
Okay, so this is tau 1 लिया मैंने. So it is V1 upon V naught is equal to Ca1. Ca naught is 0.01 minus 0.008 upon K into, बराबर. So it is 0.002 upon 0.008 K, and V1 is 4 liters and V naught. So K is equal to 1 upon 4 V naught upon 4, बराबर. So 1 upon 6 or V naught upon 16. Sorry. ठीक है, is that okay?
Yes, sir.
So we'll stop here today, and जिसको समझ में आया you can continue. इसके बाद कुछ नहीं है, PFR में सब्स्टिट्यूट करने का और निकालने का Ca2. Just like previous problem, यहीं तक जो था वो नया आइडिया था, नया अप्रोच था. Once you know the value of K, you can find out what is the value of Ca2 by using the performance equation of PFR. And that will be a homework assignment for all of you. Let's see who can do it. Next week on Tuesday, we'll see, check who was able to do it. ठीक है? Any questions before we stop?